Okay, the Section 4 lesson is going to continue with some algebra concepts that are related to a circle. And so we need to review some of our factoring and special factor pairs. And if you remember back to Algebra 1, we had two special factor pairs that were the quantity squared, either plus or minus. And those always, if you expanded a plus b times a plus b and you FOILed it out first, outside, inside, last, you would always end up with this: a squared plus 2ab plus b squared, or a squared minus 2ab if there was a minus sign. Now, why does this happen and why does it matter? If we look at FOILing something like this, we're really looking at this concept. And so if we look at the first two terms times each other, we get w squared. The outside terms, 3w. The inside terms, plus 3w. And the last terms, plus 9, 3 times 3. And what happens is outside and inside always combine, and I end up with that w squared plus, and if you think about writing it like this, there's two of them, plus 9. You can see where this 2 times the first term and the last term, 2 times the first term and the last term from here and here comes into play. If we think about doing the reverse of factoring, if I look at y squared minus 8y plus 16 as y squared minus 2 times 4y plus 4 squared, this is a perfect square in 16. 8 could be rewritten as 2 times 4. I have suddenly created something that matches this special factoring. It is a square in the first term, happens to be minus over here, 2 times the first and the last terms here and here, and the square of the last term. So I could go through trial and error, but what this special factor pair says is it's the base of the first, so the y, the sign of the middle, the base of the last one, the quantity squared. I like to think about it like packing up a pop-up book. When it's closed, you can't see those cool pop-up middle things, but the minute you open it, something pops up out of the middle. It's not that this middle term has disappeared, it's just been packed inside that quantity squared. Now, if we apply this concept of making these perfect quantities squared, we can apply that to the circle formula, because if you remember, what is the circle formula for the equation except two of these quantity squareds? And so if I could build those and force the numbers to become those, I can write the equation for any circle that I meet. And we are going to be moving to that. So let's think about this. If I have x squared minus 10x plus 25, what number goes right here? Again, this could be written as 2 times 5 times x. 25 is a perfect square of 5 squared. We've talked about you just take the base. And so if I put 5 in there, it would complete that perfect square to make that quantity be equal to the expanded form. We're actually going to do a process called completing the square. It is an algebra concept. It is something that you will also see in Algebra 2. And it's very step by step. So we want to complete the square for this. We want to turn this expression into x plus some number, the quantity squared, equals some number. And this is the number we need to find so that everything packages back into that quantity squared. So the first step is to add or subtract the constant away from the variables. So I'm going to have x squared plus 6x. If I add 7 to both sides, it equals 7. So now I have my variables alone. So what I like to do is give myself a blank. Golden rule of algebra, what I do to one side, I have to do to the other. Now, if I add the same number to both sides, I haven't changed the value of my expression, and that's the key with algebra. What I do to one side, I have to do to the other. So how do I find this number? I'm going to take half of the x term, I'm going to square it, and add it to both sides. So I take, off to the side, I take 1/2 of 6, which is 3. Now I'm going to square it. And when I square it, I'm literally going to write it as 3 squared. I'm not going to write 9. And that will be clear in a moment. Since I added 3 squared to one side, I'm going to add 3 squared to the other. Now, this, without thinking, without worrying about it, factors into one of those forms. So you take the base of the first, the sign, the base of the second, and by putting 3 here, I easily see it's 3. If you put 9 here, you potentially will make the mistake and put 9 here. The quantity squared equals 7 plus 9 is 16. That equation has the exact same value as that equation, just in a different format. I have not changed the value of the equation. Now we could go ahead and do the algebra manipulation where you could take the square root of both sides, just how you'll see it in algebra. So you'd have x plus 3 equals plus or minus 4. Since I have two things, I would have x plus 3 equals 4, or x plus 3 equals negative 4, because square roots are always plus or minus. Subtract 3 from both sides, x is 1. Subtract 3, or x is negative 7. Now that's the algebra application. Let's go ahead and do another practice, and then we'll look at how this relates to the equation of a circle. So, first step is to move this to the other side. So I have x squared plus 4x plus, leave a blank, equals negative 1 plus, leave a blank. So I subtracted 1 from both sides, but I left myself that space. Half the middle term, square it, and add it to both sides. So 1/2 of 4 is 2, add it to both sides. Now without thinking or going through trial and error, this side will package back into the base, x, the first sign, and the base, the quantity squared, equal to negative 1 plus 4, equal to 3. And that is completing the square. Go ahead and tune into part 3 of the video to see how this applies to circles.